For my real-world application project, I will be dropping this apple from this building, which has a height of approximately 4.696 meters. I will also be asking questions such as what is acceleration, what is the initial velocity, what is the final velocity, and what factors might have led to inaccurate results. So without further ado, let's start the experiment. That was the time it took to hit the ground. Now, looking back at our questions, we actually know the acceleration. Since gravity is the only force working on the object as it falls, the acceleration is equal to gravity, which is 9.8 meters per second square. We can also find the initial velocity. Since the object is at rest initially, that means that there is no velocity, or in other terms, velocity is equal to 0 meters per second. Now, we have two more knowns to add to our other two knowns, and we can use this information to find the final velocity, or the velocity of the object right before it hits the ground. The kinematic equation I chose to use was v final equals v initial, plus acceleration times time. What I did was I plugged in all the knowns into this equation. I multiplied 9.80 meters per second squared times 1.152 seconds, and I got 11.3 meters per second, 3 sig figs. So now we know that the velocity is 11.3 meters per second before it hits the ground. Yet, this actually isn't very accurate. What we didn't factor in was the air resistance. The air resistance would have actually affected the acceleration of the object while it was falling. It would have slowed it down a bit. We also didn't factor in the timing. We didn't have any equipment to measure the item exactly when it started to fall and to measure exactly when it hit the ground. If we had something that could measure it to the precise number, we would have had better results. Maybe in a future experiment, if we can account for the air resistance and somehow measure precisely when the item starts to fall when it stops falling, then we could have a more accurate final velocity. But for now, that's it. And thanks for watching.